Hey guys, hello everyone and welcome to the channel. So today in this particular video I'm going to take NAT's questions like numerical answer type questions from physical chemistry. We have already done the MCQs and MSQs in the previous video. In case you have not watched that video, so the link is there in the I button, you can watch that. And so we'll only do the NAT type questions. Alright, so let's start with it. The first question over here is from your Carnot cycle, and the question says that the reversible heat engine absorbs 20 kilojoules of heat from a source at 500 Kelvin and dissipates it to the reservoir at 400 Kelvin. The efficiency of the heat engine is. So how to do this? So first of all, TC means temperature of the cooled substance, that is 400 Kelvin, and TH means the temperature of hot substance, that is your source, and that is 500 Kelvin. The formula to calculate efficiency is eta is equals to it is like TH minus TC divided by TH. So if you do that, you are going to, or you can use this 1 minus TC upon TH. Okay, so with that you are going to get 1 minus this particular thing is going to give you TC is your 400, right? So 400 divided by 500, and on solving this you are going to get 20% as the answer. Okay, so your eta is going to be like 0.20, and that means it is 20% as the value. All right, so this is how it will be done. It was pretty simple question. The next question is from your kinetics. It says given the initial weight of 1 milligram of radioactive substance, half life is given to you, the amount of it disintegrated in 1 year is, okay, you have to round off up till the 2 decimal places. All right, so to do this particular question you have to use the radioactive decay formula. So your decay constant lambda is given by 2.303 upon T, and you have log initial concentration or initial number of moles divided by the final amount or the final weight. And you know that half lifetime is given to you, so you can calculate lambda as 0.693 divided by T half. Okay, this is the formula. So you can put the value over here. So this will become 0.693. T half is given to you as 5.27 years. Let's keep it like that only. 2.303. The time is 1 year, so I am keeping it 1. Then you have log initial value is 1 milligram. So keep it 1 mg, or let's write it down just like 1. We'll get the answer in milligram only, so let's not convert anything. The final weight we don't know, so let it be x. Solve this whole, and basically on calculating this you will get log 1 upon x, and this particular part is going to be equal to, I have done it already, so 0.05709. this is something you will get. 1 upon x will be anti-log of that, so 1 upon x will be anti-log of it, or basically 10 to the power this whole value. Okay, so 10 to the power your 0.05709. so you can put it using the calculator. You will get 1 upon x is equals to 1.14, or you can say that your x is going to be equal to 0.876. now this is the amount in milligram which will be left after 1 year. Okay, so this is the amount which will be left after 1 year. So how much amount is disintegrated? They were asking the amount disintegrated. So disintegrated amount is going to be 1 minus this. So 1 minus 0.876. On solving this you will get 0.123. the answer will be something like 0.12 milligram. This is going to be the final answer, or 0.12 or 0.13 is going to be the answer for this particular question. All right, let's see the next one then. And let's do this one. It says that a laser Raman spectrometer operating at 532 nanometer is used to record the vibrational spectrum of Cl2 having a fundamental vibration at 560 centimeter inverse. The Stokes line corresponding to this vibration will be observed at. So to do this particular question, first of all you are given with the wavelength of the Rayleigh line. Okay, you have to convert that into wave number. So you have to first of all find out like wave number of Rayleigh line. So this is going to be equal to 1 upon and 532 into 10 to the power minus 7. Why? Because I am going to convert this in centimeter inverse. So fine, on solving this you can also write it down 10 to the power 7 divided by 532. On solving this whole value, your Rayleigh wave number is going to be 18796.99. okay, So this much centimeter inverse will be this value, or you can call it as 18797. Okay, so this is 18797 because everything has to be in integer, so I'm keeping this in integer itself. Now your Stokes line, okay, or the first Stokes line is given by your Rayleigh wave number, okay, your Rayleigh wave number minus your fundamental frequency. So that's how we calculate it. And if you have to find out anti-Stokes, it will be added, okay, because you know the Stokes line are towards the left side of the Rayleigh line, so that's why it has to be subtracted. So 18797 and minus the value is 560. You have to just subtract it, and the answer will be 18237 centimeter inverse. This is going to be the final answer, 18237. All right, so this is how it will be done. You can check out your answer. I might do little bit of calculation mistake, but I think whatever I am doing is best from my knowledge. Okay, let's take the next question. The next question over here says that the number of photons emitted per nanosecond by a deuterium lamp and at 400 nanometers having power of 1 microwatt. Okay, so first of all you need to find out this is the wavelength of the light coming out from the deuterium lamp. So you need to find out the energy of one photon. Okay, so energy of one photon, that is going to be equal to, like, that can be calculated as h nu or hc upon lambda. So that means you just have to put it everything. So h is 6.6 into 10 to the power minus 34 multiplied by c. You have to put it in meters. Let's say we are putting everything in meters because this h is also in meters and this is also in meters. So that means 3 into 10 to the power 8 and divided by lambda will be 400 multiplied by 10 to the power minus 9 meters. Okay, so this is going to be the energy of one photon. Total energy is given to you. Total energy is given to you as 1 microwatt. 1 microwatt. What does that means? It means 10 to the power minus 6 watt. And 1 watt is equals to joule per second. So that means this is 10 to the power minus 6 joule per second. Okay, this is the total energy which we have. Now we know the total energy, we know the energy of one photon, so we can divide this to get our answer. Okay, so what you have to do is you just have to divide this total energy with the energy of one photon. So number of photon, 10 to the power minus 6 divided by 6.6 into 10 to the power minus 34 multiplied by 3 into 10 to the power 8 and divided by 400 into 10 to the power minus 9. Okay, so you just need to solve this whole thing, and on solving this you will get 2012.37 divided by 10 to the power minus 9. Now what they were asking is number of photons emitted per nanosecond. Now 10 to the power minus 9 is your nanosecond, right? That's the value of your so this is going to come in seconds. Okay, this much photons per second. So these many number of photons, this is going to come in photons per second. What you want to find out is number of photons per nanosecond. So you have to remove this value or you have to divide by this value, that is going to get cancelled out, and number of photons per nanosecond will be 2012. Okay, this is going to be the answer, 2012, because you have to put it in integers. So yeah, 2012 should be the answer of this. All right. Okay, let's take the next question. All right, talking about this particular question, it says that the 5-volt battery delivers a steady current of 1.5 ampere for a period of 2 hours. The total charge that has passed through the circuit is in coulomb. Now for this we will use Q is equals to IT. This is the formula which we are going to use. So I is given 1.5 ampere, time should be in seconds. So that's 2 hours, that means in 1 hour we have 3600 seconds, so let it be. So multiply that and you will get your answer in coulombs. So the answer is going to be 10800 coulombs. Okay, this will be your answer for. All right, let's go for the next one, the next NAT which was asked. All right, this question over here says that the de Broglie wavelength of an argon atom mass is given to you, traveling with the speed of light is. Okay, so de Broglie wavelength was being asked. To do this question, you need to know this formula, lambda is equals to h upon mv. Put all the values. Now one thing which you have to be very careful is that the value of h is in kilograms. So you have to convert the mass in grams from AMU to kilograms. And also one more thing is that you have to convert this per mole unit. Okay, so that's what it is going to be. So the value which you are going to get is this, that is 6.6 into 10 to the power minus 34 divided by the mass will be 40 into 10 to the power minus 3, that is going to get converted into kilograms, and divided by the Avogadro number, that is 6.022 into 10 to the power 23, and multiplied by the velocity of the speed of light which is given to you. So the speed of the beam, sorry, which is 250. Okay, so this is what you will be having, and just multiply and solve this whole thing and you will get something around 39.9 picometer. Okay, this is going to be the answer, 39.9 picometer. You can do and check it out, the answer of your own. Okay, the next question, the next NAT which we have is from this. This says that the molar absorption coefficient of a substance dissolved in cyclohexane is 1710 liters per mole per centimeter at 500 nanometer. The reduction in the intensity of light at the same wavelength that passes through the cell of 1 millimeter path length containing 2 millimolar per liter solution. Okay, so let's try to do this. Okay, fine, I have solved all the questions, so I am just taking my reference from there, right? So you are given with your molar absorption coefficient, that means epsilon value. Epsilon is given to you as 1710. Remember to write down the units because everything is on unit only, because apart from unit the question was very simple. Then you are given with the length, and length is how much, that is, okay, the path length, that is how much, that is 1 millimeter. What about this 500 nanometer? You don't have to do anything with that. Okay, so just leave that thing. So 1 millimeter is the path length, and then you have the concentration, that is 2 millimole per liter. Okay, so let's convert everything. First of all, the epsilon is in centimeter inverse, so convert length in centimeter, that will become 0.1 centimeters. C is in millimoles, so convert that into moles, so that will be 2 into 10 to the power minus 3. Okay, this will be now moles per liter. Now you have everything. Now you put in the formula of A is equals to epsilon CL. Epsilon is 1710, C is 2 into 10 to the power minus 3, and L is 0.1. Solve this all and you will get your absorption value as 0.342. This is the absorption value. Once you got your absorption value, you can find out the transmittance. The transmittance is equals to 10 to the power the absorption minus absorption value. Okay, that is going to be your transmittance. So that means 10 to the power minus 0.342. Solve this whole thing and you are going to get 0.4549. Okay, this is your transmittance. Okay, so this is going to be transmittance. Let me just recheck this because I think that's the correct value. So I have okay, yeah, fine, so this is correct. Okay, that's what I have. Okay, so this is your transmittance. So this much amount of light is transmitted. Okay, or in percentage if I express this thing, so this will be 45.5. Okay, 45.5% is transmitted. So what is the amount of light which is reduced? Okay, so the reduction in intensity, will be how much? That will be 100 minus 45.5. The answer is going to be 54.5%. Okay, so they were not asking you about the transmittance, but they were asking you that how much the intensity is going to get reduced. Okay, so this is how this question will be done. I hope this is much clear. The next NAT is based upon your kinetics. It says that the rate constant of the decomposition of molecule in the presence of oxygen are this and this at two different temperatures. R value is given to you. The activation energy of this particular step is. Okay, so you are given with your K1, that is 0.237 into 10 to the power minus 4, and you are given with K2, that is a 2.64 into 10 to the power minus 4, and temperature is also given to you. T1 is 273 Kelvin and T2 is 298 Kelvin. Okay, fine. So everything you know now, you can put it in the formula. So ln K2 upon K1 is equals to EA upon 2 point, or because we are putting in ln, so don't need to put 2.303. So EA upon R, and in the bracket 1 upon T1 minus 1 upon T. Put all the values here. Put the values of K2, K1, T1, T2, EA you have to calculate. R will be substituted as this, and that's all. You don't have to change any unit in this question, just directly you have to do. Later on you just have to put, the answer will come out in joules, you have to like convert that into kilojoules. So the answer will come out something around 65.2. This will be the answer. Okay, 65.2 kilojoules per mole is going to be the answer for this question. Okay, let's go to the next numerical type question which was asked. All right, here it is. The question here says that the fundamental frequency of Hi is, and it is given key is actually the fundamental frequency is given to you, that is 2309 centimeter inverse. They are asking the force constant. Okay, so they are asking you to calculate the force constant over here. Fine, so this is pretty simple. You just have to do it like this. The frequency, fundamental frequency is given to you as 2309 centimeter inverse, and you know that this is equals to 1 upon 2 pi c under root k upon mu. Okay, this is what you have. Now one thing which you have to be very careful is that unit is in mks unit. You have to put the mass in kilograms. So reduced mass has to be converted into kilograms. So reduced mass is m1 m2 upon m1 plus m2. So 1 into 127 divided by 1 plus 127. This becomes 127 upon 128. This will be in grams. So convert this into kilograms and then divide it by Avogadro number, or you can simply multiply by 1.6 into 10 to the power minus 27, and this will make it in kg. Okay, this will convert this mass into kg. So this is something which you have to do. If you have not done this, then answer will not be correct. Now once you got this, you have to calculate your k. So that means your mu bar into 2 pi c, okay, multiplied by under root mu is equals to under root k, or you can say that your k is equals to mu bar 2 pi c whole square and mu. Just put all the values now. Mu bar is given to you as 2309 multiplied by 2 into 3.14. Speed of light is given to you in mks only. So what you have to do, see, since you are putting your wave number in centimeter inverse, so this is speed of light, you don't have to take directly, you have to convert this in centimeters. So this will be 3 into 10 to the power 10 centimeter per second. Okay, and then square this whole thing and then multiply with this mu, that is 127 upon 128 into 10 into 1.6 into 10 to the power minus 27 kg. Solve this whole thing, and that is what is going to give you the value of k. The value of k will be 313.56 Newton per meter. Okay, this is the value of k which you will get. Since it was asked up to the nearest integer, so 314 should be the answer. Okay, that should be the answer for this question. All right, let's go for the next one. It says 2 liter of gas at 1 atm pressure is reversibly heated to reach final volume of 3.5 liter. Absolute value of work done of the gas is being asked in joules. So here you have to use the formula W is equals to minus P delta V. So the external pressure is 1 atm, volume like V2 is 3.5, V1 is 2 liters. So just put all these values. So minus 1 and V2 is 3.5 minus 2, and you will be getting minus 1.5, but the unit is going to be 8 liter atm. Okay, because the volume is in liter and the pressure is in atm. So liter atm will be the unit of work done, but they're asking the value in the terms of joule. So you should know how to convert liter atm into joules. I hope you have done previous years of question of GATE, and if you have done, there it was given that how to do it. I think in GATE 2019 a question was asked where the values of gas constant was used to convert, to make the conversion. So the same thing we are going to use. This particular thing is going to be like work done will be minus 1.5 multiplied by 8.314 and divided by 0.0821. Okay, this is in liter atm and this is in joules. Okay, so now, and this was already in liter atm, so liter atm will get cancelled out. You will get the value in joules. Solve this and you will get the value. So work done will be approximately equal to minus 152. So the answer is going to be minus 152. But one more thing I want to make it clear over here, that in the question it was asked that the absolute value of work done on the gas, how much work is being done on the gas. So work done on the system is always positive, so you don't have to put minus sign. The answer will be 152. If you have written answer positive, it will be correct. If you have given answer negative, I think that will be incorrect. Okay, according to me, that's what I think, and that I think it is correct only. Okay, so this is how it will be done. All right, so after recording some of the question, I found that I just skipped one or two. So let me add them as well. The question over here was left out. The question is question number 46, and it says that the vapor pressure of toluene, okay, molecular weight is given to you is 0.13 atm, and at 25 degrees Celsius, if 6 gram of hydrocarbon is dissolved in 92 gram of toluene, the vapor pressure drops to 0.12 atm. The molar mass of the hydrocarbon is being asked. So what we have to use, first of all, we will find out the number of moles of toluene. Number of moles of toluene is given weight. Given weight is 92 grams. Molecular mass is also 92. So that means 1. Number of moles of toluene is 1. Number of moles of hydrocarbon will be, the given weight is 6. Molecular mass we don't know. Let it be m only. Okay. Now we know that relative lowering of vapor pressure is given by P naught minus P divided by P, and this is equals to the mole fraction of the species which you are doing. So because you are adding the solute, so that's why mole fraction of solute will be there. P naught is already given, that is 0.13 minus P is the pressure where it came after dropping, so that is 0.12 divided by 0.12, and this is going to be equal to XB. XB is going to be the number of moles of B, or basically not B, it should actually, I should call it XH. Okay, that means the number of mole fraction of hydrocarbon. So it will be NH upon NT and plus NH. Okay, total number of moles. When we will solve this, we will get like 0.01 divided by 0.12, and on the other side I'll get 6 upon m divided by 1 plus 6 upon m. You have to solve this up, and on solving you will get m is equals to 72 grams per mole. Okay, this is going to be the molecular mass of your hydrocarbon. 72 should be the answer. Nearest integer was asked, and you will get the answer in integral value only. The answer will be 72. All right. The last question for this particular video will be here. It says that the change in enthalpy delta H of the reaction is being asked, is given, actually the delta H is given as minus 243 kilojoules, and it is said that if the amount of phosphorus consumed is 3.1 grams, they are asking the change in enthalpy. So for this you just have to use the stoichiometric relations. So that means here you are given with delta H for your 2 moles. According to the reaction, you see that delta H for 2 moles of phosphorus is actually given to you. Okay, so what you have to do is you have to write down like this: 2 moles of phosphorus gives delta H as minus 243 kilojoules. Okay, now you have to write down for do it for the given. First of all, convert this value, whatever is given, convert this in number of moles. So 3.1 grams, that means how much? 3.1 divided by the molecular mass is 31 for phosphorus, so this will become 0.1 moles. Okay, so 2 moles of phosphorus is this much. 1 mole of phosphorus, okay, 1 mole of phosphorus will be minus 243 upon 2 kilojoules Okay, kilojoules is going to be the enthalpy of this. And if you are trying to do it for 0.1 mole, or you can say that 3.1 gram or 0.1 mole of phosphorus will be how much? If 1 mole is this much, 0.1 mole will be minus 243 divided by 2 and multiplied it by 0.1. Solve this whole and your answer will come out minus 12.15. okay, so this is going to be the final answer for this question. So these were the questions from numerical answer type in your GATE 2021 exam. I hope all the questions are much clear to you. I have tried to explain you also in a little brief manner so that it just does not take much of your time. You can match your answer. Probably I might do one or two wrong also. It's not like I'm like I have done everything correctly only. So if there is some scope of correction, do let me know in the comment section below. If you think that there is some mistake in any of the calculation, you can just tell me in the comment sections below. And that's all from my side for this particular video. I'll see you guys in the next one. Till then, have a great day.